All right, last two examples here. So first one, it's asking us to find the antiderivative of tan x. So tan x is the one that we didn't really give you the formula to on that first page. So we're going to work it out now. So taking the antiderivative might not be immediately apparent how we can use substitution, but if you guys remember, tan x, this is the same thing as saying the antiderivative of, we're going to rewrite this as sine x over cos x, so cosine x dx. Now, from here, I'm saying I see two expressions. Is one the derivative of the other? And I realize, yeah, cos is the derivative of sine. So don't write any of this down yet, but I said, yeah, cos is the derivative of sine, but the issue is that cos is in the denominator. So if I went and I, did use substitution and put du in the denominator, which we don't want. We want to have du in the numerator. So we want du to be sine x. So we say, is there any way that sine can be the derivative of cosine? And we say, well, if we remember with our trig functions I'm just going to write it over here, but our derivatives, it would be like sine. If we take the derivative, goes to cosine. Derivative of cosine goes to negative sine. And that goes to negative cosine. And then we're back to the beginning. So I see, yeah, cosine can go to negative sine. So we're missing that negative sign though. So if we put a negative here with the sign, multiplied by a negative here, and then multiply by a negative on the outside, that's the same as multiplying by a negative 1. So now I'm able to make it so my u is going to be that cos x and my du is going to be that negative sine x. So now my du is in the numerator. Now when I do this, I'm going to go ahead and substitute everything in. I'm going to have the negative integral, negative sine dx becomes, sorry, I forgot the dx here. So negative sine dx is just becoming du over our cos x is just becoming u. And this is the same thing as negative integral u to the negative 1 du. You don't have to rewrite it like this. For me, I usually do, but you don't have to. And I know the integral of u to the negative 1, so the antiderivative of that is just going to be ln, so the natural log. So negative ln the absolute value of u, du goes away, and plus c is still there. So we're going to have negative ln absolute value. My u is cos x plus c. All right. moving to this last one. Alright, I am going to show this to you through basically a double u substitution. You might see it right away, but I'm going to show it by doing u substitution twice. So the first thing that happens when I look at this is I see like, alright, we have this 5x in parentheses. So I'm going to say u equals 5x. So my du, my derivative of u, is just going to be 5 dx. Now, here, I don't have the 5 on the outside, so I'm going to put 5 on the outside, 5 here, and outside the integral, I'm putting the 1/5, because 5 times 1/5 is 1, so it's like adding nothing to this integral. So, now I have 1/5 the integral, make my substitutions, and I'll have ln the absolute value, or sorry, not absolute value, ln u over x d. Yeah. Basically this du. So this is a little bit weird here, but if I look, I still can't do anything with this integral because I still have two expressions multiplying or dividing each other. So I need to do another round of u substitution. So this time, I see that one of these is the derivative of the other. So I see this x here, so I can rewrite this as like 1/5 integral x to the negative 1 ln u du. I can see this x to the negative 1 is the derivative of ln. So what I can do is now like a v substitution, where I say v equals this ln of u and dv equals, I'm going to say x, then negative 1, chain rule, du. So that's going to give me 1/5 integral, so it'll be 1/5 the integral. I'm replacing this ln u with a v, and it'll be here, this x and negative 1 and du are becoming dv. So now, really easy to integrate. I'm just using my reverse power rule, and I have 1/5, and this is going to be times, well, be v squared here, And then this is going to be 1 over 2, because I need to multiply by the reciprocal, or divide by my new exponent, plus c. Now, from there, I'm going to say this will be 1 over 10. And I'm going to do, instead of v, I'm putting, it's going to be ln of, and instead of u, remember, it'll be 5x this whole thing squared plus c. Instead, if you would like to, you can just make this whole expression at the beginning. You could have just done u equals ln 5x and just set du equal to 5 times 1 over x, same as 5x to the -1, and just substituted from there. I showed it to you with a double substitution. You could have just used this one substitution and gone from there. All right. From here, it's problem set, and I will post answers to that as well.